In this video, we'll explain how CA2600 semi-normal patching operates. In a standard analog synthesizer, the connections between each voice component are hardwired. In other words, they're permanently connected inside the synth. In this diagram, the orange boxes represent a basic synthesizer voice, and the white arrows represent the hardwired connections. When I play a note, the pitch CV's internal connection tells the oscillator what pitch to play, and the gate CV enables the envelope generator, which in turn controls the voltage-controlled amplifier, and voila, we hear sound. Now let's say we dump that dusty old hardwired synth on eBay and get ourselves one of those newfangled modular synths the kids are all talking about. In a modular synth, all of the components are independent blocks, and if we want to hear sound, we'll need to run some patch cables. First, we'll set up the control voltages for pitch, gate to the envelope generator, and envelope generator to the VCA. Then we'll hook up the audio portion, running a cable from the oscillator output to the filter input, and from the filter to the input of the voltage-controlled amplifier. And now we can play notes just like our hardwired synth. Modular synths are great, but the downside is that we need to patch cables every time we want to hear sound, as well as any time we want to route a modulation destination. So let's check out how a semi-normal patching scheme works. Now this looks pretty similar to our initial hardwired synth voice, but you'll notice the jack's situated in between each module. As it stands, the jacks don't affect anything, and it can be played just like our hardwired synth. Now let's add a noise generator to the equation. This isn't plugged into anything, but if I take its output and plug it into the jack between the oscillator and the filter, the oscillator signal gets interrupted. That is, the noise generator I plugged into the jack replaces the normal oscillator connection. If I play a note now, we hear the noise generator in place of the oscillator. This is the main concept of semi-normal signal routing. This works the same way for control signals. Let's swap out our noise generator for a low-frequency oscillator. If we look at the ADSR envelope generator, you can see that its output is normalized to the VCA input. Normally this would shape the amplitude of every note that's played, like this. But if I patch a cable from the low-frequency oscillator to the VCA's control input, the ADSR connection is replaced by the LFO signal, and now I don't even need to play a note to hear sound because the envelope generator that was previously controlling the VCA has been replaced by the LFO. Though this is a tremendously simplified diagram, this is exactly how CA2600's audio and control input signal routing works. Next to each normal jack is a small box with text or an icon. These tell you what the normal signal source is if nothing is plugged into the jack. You'll also notice that almost all of the normal inputs have a vertical or horizontal attenuator slider. These attenuators control the amount of signal coming from either the semi-normal or patch cable input.